Okay, so chapter 9 is about what's called quadratic functions. Okay, I love chapter 9. Love chapter 9. I will be honest with you, I'm going to kind of mix things up a little bit with how I normally do these. The first thing we're going to talk about doing is how to graph quadratic functions. We're going to spend the rest of the week on this. So today is just going to be kind of an introductory lesson, a lot of vocabulary, and different points on the graph. I don't normally do it this way, but I wanted to try to mix things up because sometimes I just don't feel like it sinks in exactly how I would like it to. So if it doesn't go well, I'm sorry. Okay, so the first thing I need you guys to do is I need you to go ahead and just create like a little book. So if you haven't done this already, just go ahead and fold it so that this should be on the front. And then when you open it up, that should be like the middle of your book. Okay? Okay, so let's start here on the front. So this is in color. I really like the color coordinating. So if you want to, if you have like highlighters or some colored pencils and want to kind of color it along on your black and white, that might not be a bad idea just because it kind of helps maybe bring attention to the different parts of a quadratic function. So far all year, for the most part, if we've talked about graphs, we've talked a lot about the graphs of a linear function. Now the graph of a linear function, it's just a line. And really whenever it comes down to it, the graph of a line is really simple. I mean, it's just a line. If you have 2 points, you have a line. That's definitely the simplest of all of the graphs that we have. A quadratic function is definitely not a line, okay? The graph of a quadratic function is called a parabola. Now, one thing that we're going to talk a little bit more about tomorrow is what exactly a quadratic function is in equation form. So a linear function is going to be in the form y equals mx plus b, where m is your slope, b is your y-intercept. The graph of a quadratic function is going to be in the form y equals ax squared plus bx plus c. The big thing with the quadratic function, whenever you see the function, when you see the actual equation itself, you're going to see an x squared, which we just got done factoring, right? In chapter 8, we have a bunch of x squareds. That's why this leads right into this chapter here. So, keep in mind, and I think we talked about this earlier this year, when you graph something, when you graph whether it's a line, whether it's a parabola, if it's a square root function or a absolute value, whatever it is, what you're graphing are solutions for the function. So keep in mind, a function has inputs and outputs. You plug in x values, and when you plug something in for x, it spits out a y value. And every time you plug in an x and it spits out a y, you get an x comma y that you can plot on your graph. But that's not the only solution. You can plug in something different for x and get out a different y. And then plug in a different x and you get out a different y. If you were to plot all of these points, that's the picture that you see. That's the graph. So when you do that with a quadratic function, you are going to get a parabola. A parabola is a U-shaped curve. So a lot of times they're going to look like this, but they can also be flipped upside down. Okay? Now, a line is pretty simple. It's just a line. But a parabola, since it's a curve, it's got a bunch of different parts. Okay? So let's start here first with what's called the vertex. Okay? The vertex. The vertex is a point. We're going to be really, really interested starting tomorrow how to find that vertex given the equation. Okay? The vertex, I kind of think about it as it's kind of like the middle of the parabola. It's where we're going to start. Okay, whenever we start graphing quadratic functions tomorrow. But it's going to be just kind of like that center of the parabola, but it is a point. So the vertex of this parabola is 0, -2. So if I ask you for the vertex, I'm asking you for a point. Okay? Now the next piece is what is called the axis of symmetry. Okay, now this one always gets confusing. The axis of symmetry is a line. That's not my highlighter. highlighter. There we go. The axis of symmetry is a line. It's not a line that is solutions of the graph, but it is the line that cuts the parabola in half. So it's kind of like the line of symmetry. It's going to run straight through the middle of the parabola, which means it's going to run straight through the vertex. Now, for the parabolas in Algebra 1, they're always going to open up or down. So the line that cuts it in half is always going to be a vertical line. Okay? In Algebra 2, you might have one that goes this way. But for Algebra 1, it's always going to be a vertical line. And if you remember from whenever we were graphing back in Chapter 5, if it's going to be a vertical line, it is always going to be an x equals. So when I ask you for the axis of symmetry, I'm asking you for a line, which means you need to give me an equation, because that's the only way we can say here's this line. So this axis of symmetry is x equals 0. Goes right through 0. Okay? Now, the other parts are what we call zeros. Okay? The zeros of a function, these are going to be these 2 points right here. Okay? These are going to be any number that make the value of the function 0. Now, keep in mind, this brings back to function notation. When we did function notation, we would say like f of x equals x squared minus 2. That's what this function would be, okay? What the zeros are is it says anytime what makes the value of the function 0, this is the value of the function. This is your y. This just wants to know the zeros of the function are the points on the graph where y is 0. And if you think about it, any points where y is 0 are the points on the x-axis. The zeros are the x-intercepts. The zeros are going to be those 2 points where your graph crosses the x-axis. Okay? Most of what we're doing today, actually all of what we're doing today is vocab. Okay? It's just a bunch of vocab, all right? So that's kind of the basics. Okay, we have the vertex, that's the center point. The axis of symmetry is a line that cuts it in half. The zeros are where it crosses the x-axis, and those are also the points. Questions on that part? Okay, now in the middle, this is the part that I'm kind of mixing things up and I'm doing them a little differently because it's something that doesn't always seem to click in, or doesn't always seem to click, I feel. Okay. Domain and range. We've talked a little bit about domain and range. Just a little bit, okay? Domain are your inputs. They're the x values. Now, whenever we've done this in past, you've just been given like a table, and you just have to list out the x values. So that's what x could possibly be. And then for the range, those are the outputs, the y values. When you plug this in, here's what you get out. So in the past, what we've done is just, okay, whenever you plug this in for x, here's what you get out for y. You just listed out the numbers. That was kind of a limited function here, okay? If you're looking at a real function, your domain and range are going to be a little different. And I will say that this looks a little different than your printout because I had some of this over on the wrong side. So this right here, there's 2 ways to write the domain and range. That's actually over on the right-hand side. It shouldn't be. It should be over here, okay? So the domain and range, this is the part that I'm going to try new, okay? So if you have a highlighter, I'm hoping this helps, okay? The domain is the part of the x-axis that the function covers. So for domain, you are looking at your x-axis. So if you look at this function, I've got this little zigzag line. It's not actually a real equation or anything. I just drew it on there, okay? To find the domain, you are looking at the part of the x-axis that function covers. So to show you what I mean by that, and don't highlight this part, it's not right. Right there, see how there's no function on that part of the x-axis? You guys see that? There's no function up here. You see that? Okay. The function doesn't start until here. Here. Right? Okay. There is a function, once again, we're looking just at the x-axis. There is a function here, all the way here, and then it stops there. That's the part of the x-axis. Does that make sense? Okay. The range is just kind of the opposite. The range is going to be the part of the y-axis the function covers. So, I mean, you do basically the same thing. If you look up here at like 5, there's no graph up here. See that? The graph starts on the y-axis right here. And it goes down all the way to what, right there? Okay. That's what the range looks like. Okay, so do you guys see the domain and range? Okay, now what we have to do is we have to be able to put that into words. Okay, so there's 2 ways to write domain and range. I think probably it's easy, well, it's probably easier in interval notation, but I would accept either one. So the first way you could do it is as an inequality. So if I want to start with the domain, remember the domain is x values. If you're going to write it as an inequality, what you're going to do is you're going to write the smallest value and then the largest value. Okay? So the smallest value on my x-axis that my graph covers is that right there, right? Which would be -4. So your domain goes from -4. Now, so -4 is less than or equal to x, which is, this is how you're going to write this, less than or equal to, and then you're going to write the largest value that x can be. So my domain also goes all the way to the right here until 3. What this means is your domain runs from -4 to 3. You can also write this in what's called interval notation. Okay, so interval notation just basically says my domain starts at -4 and ends at 3. So -4, 3 means that this is the range from -4 to 3. Now with interval notation, there's really only one type of grouping symbols that you need to be familiar with for this one. You're going to use square brackets. Those square brackets, they mean that the endpoints are included. It means that it's an equal to, because it could be -4, it could be 3. At some point, if you end up where you don't want to include the endpoints, you would use parentheses if it was just a less than or just a greater than. Okay? And I can do the same thing for the range. So you want to start with your lower limit, your lowest value. So if you look at the range, you're looking at that lowest value. What's the smallest number that y could be? What is that? -2. So for your range, it starts at -2, which is less than or equal to y, because your range is the y values, and it goes all the way up to 4. And interval notation, it would say -2, 4 with brackets like that. Square brackets like that. Either way, how you write domain and range doesn't matter to me. Okay? Okay, now, that's for the little squiggly function, which I think is easier to see rather than on a quadratic function. Now, the idea is still the same, okay? For the domain and range, okay, it's the same idea, except I think it gets a little confusing. So let's start with domain, because here's the thing. For a quadratic function, domain is going to be the same for almost every single one, okay? Because these arrows on the end of any function means that it keeps going forever and ever and ever. And although it kind of looks like a parabola starts going straight up, it never does. This parabola continues to go up and out forever and ever and ever and ever and ever. So here's the thing. If it goes to the left, up and out forever and ever and ever, it covers the entire x-axis that way. Because it keeps going out forever. It covers the whole x-axis. There's not like you see on the last one how there was like an endpoint and an endpoint. There were no arrows on that function, right? It started here and it ended here. These arrows mean it goes that way forever. It covers the whole axis. It stretches left and right forever. So this domain is actually going to extend that way as well. So the domain for almost, and I say almost because I don't want to just always say always, all right? It's going to be all real numbers. Any real numbers. It covers the entire x-axis. It's going to be all real numbers. Now, the range is going to be more like what we did on the last one. The range, guys, there's no function down here, right? Remember, for the range, you're looking at the y-axis. You wouldn't be able to highlight that part of the y-axis because see how there's no graph down there? Right? Your graph, your function starts here, but then it goes up forever and ever and ever. It doesn't go down forever and ever and ever, but it starts here and it increases. So to do the range, remember we're talking about y values. Since it starts here and these numbers get bigger, it goes up, I know y could be anything greater than or equal to, what is that y value? -1. Your range is y is greater than or equal to -1. And I can do the same thing on this one. Notice, for the domain, these arrows mean that it stretches to the left forever and ever and ever. As much as it may look like it just starts going straight down, it never does. It keeps going to the left forever and ever and ever. It keeps going to the right forever and ever and ever. It covers the entire x-axis. It's going to stretch to the left indefinitely. It's going to stretch to the right indefinitely. So just like the last one, your domain is going to be all real numbers. Now the range, this time notice, there's no graph up here. For the range, you're looking at your y-axis. This graph starts on my y-axis right there. And then, look, there's a graph here, there's a graph here, there's a graph here, and those arrows mean there's still a graph all the way down there, even though I don't see it. So for your range, remember we're talking about y values. Now this time, notice they start at this point right here, and they get smaller, right? They're going down. So y has to be less than, smaller than, what's that point right there? 2. That's how you do domain and range. We'll practice more of that when we get into examples, okay? Questions on that? Okay, then the last thing we're going to talk about is minimum and maximum, which is super related to what we just talked about. So, the minimum and or maximum refer to the smallest or largest y value for a function, okay? And I think I had written in my notes, it's kind of like the tallest point and the lowest point. You're talking about height. How high does the function get and how low does the function get? So what we're looking for here, the maximum, can you see it? The highest point? It's right here, right? This right here is the maximum. And I know you guys have writing there, so just like scribble it out. Now the maximum is the height. How high did that function get? What is that maximum value? What is it? How high did that function get? What is the maximum value? 4. Your maximum value is 4. And then you can do the same thing with the minimum, which is like the lowest point, right? Can you guys see the lowest point? Right? It gets kind of low right here, but this right here, that's even a little bit lower. That right there is your minimum. You guys see that? Okay. And what is that minimum? How low did it get? It went all the way down to -2. It doesn't get any smaller than -2. Okay, does that make sense, seeing the minimum and maximum? Okay, now, a quadratic function isn't going to have both a minimum or maximum. It's going to have either a minimum or a maximum. Okay, because watch this. If I look at this graph right here, okay, if I'm like, okay, what's the maximum value? Here's the problem. Those arrows mean that this graph goes up forever and ever and ever. There is no end up here. It doesn't like come up and then come back. It never does that. There is no maximum here. But there is a minimum. Right there. That's the lowest point on this graph. So the minimum is how low did it go? How low? -1. So this has a minimum at -1. This graph is the opposite. Notice, it doesn't have a minimum. It keeps getting smaller. It goes down forever and ever and ever. It never hits a low point. But it does right there. Right here. This one has a maximum. What was that highest value there? 2. Okay, do those make sense? Okay, let's get this. Oh, should we need to start a new table of contents? I have no idea where we're at on page number. I'm going to need help with that. What was the last? It would have been your 8 notes. What was that page number? Again. Anybody say that number? 31 was 8, or 31 was 31, 32. Okay, so this should be page 33. So your table of contents is going to be page 33. So page 35 is where you're going to glue this 9.1, and it's going to be graphs of quadratic functions. Okay, so like I said, I've never approached it this way before, so we'll see how this goes. We're just really focusing on the vocabulary today and kind of recognizing the different parts of a quadratic function. And I'm hoping it'll make it easier tomorrow whenever we come back around to graphing. So this is exactly what you're going to have to do on your homework, the exact same thing, okay? For each function, we're going to identify the vertex, the axis of symmetry, the zeros, domain, range, and then minimum and maximum value, okay? So for the first one, all right, so we have this quadratic function, we have this parabola here, okay? The first thing we want to identify is the vertex. Now what I like to do is I like to actually draw it and kind of point it out. The vertex, that's right there, right? It's that middle point. Now, it is a point. It is an x, comma, y. So when I ask you for the vertex, I'm asking you for a point. So as an x, comma, y, the vertex is at 2, comma, 1. Now what I would kind of like you to do when you get to your homework, when it asks for the axis of symmetry, and we're going to have to do this tomorrow anyway, I want you to draw the axis of symmetry. It's just the vertical line that cuts the parabola in half. We typically draw this as a dotted line because it's not solutions of the graph, but it is nice to see. You can see that it cuts it in half. Now, when I ask you for the axis of symmetry, I'm asking you, what is that line? It's not a number. A number isn't a line. It's an equation. And I promise you, it is always going to be an x equals equation because it's always going to be a vertical line. Now, on that vertical line, what does x equal? 2. Yeah, x always equals 2. That's your axis of symmetry. X equals 2 is what cuts it in half. Now, the zeros, I didn't really think of this as I was going through this. The zeros, if you remember, okay, that's the x-intercepts. It's where your parabola crosses the x-axis. Does this parabola ever cross the x-axis? No. So the zeros here, there are none. There are no zeros here. Now the domain, remember the domain are the x values. So this is where you're going to highlight the x-axis. Any part of the x-axis that is covered by the function. Now, although it may be tempting to just highlight that part of it, because on this graph, what's graphed, that's all it covers. Remember what those arrows mean? It keeps going to the right forever and ever and ever. It keeps going to the left forever and ever and ever. Although it only covers that part of the x-axis on what I graphed, those arrows are there to show me it doesn't just cover that part. So your domain, and I hate to like spoil this for you, it is always, almost always going to be all real numbers. Okay. Now the range is where you have to think a little bit, because the range is the y-axis. Okay. So you're looking on your y-axis. You can't highlight anything down here. My graph starts here, and then there's a graph here, there's a graph here, there's a graph here. So if you can see it, okay. Now remember, the range are the y values. So it's going to be y is, and it's going to be some inequality dealing with y. Now since it starts at this value and gets bigger, it goes up. These are the y values greater than or equal to, what is that number? 1, right? 1 and anything bigger than 1. So the y values have to be anything greater than or equal to 1. Okay, and then the last two things, you have to decide first. Is this, okay, does this graph have a minimum value, right, a low point, or does it have a maximum value, kind of like a lid on it? a minimum, right? It's got that low point. So we'll just say, okay, it has a minimum. That point right there, what is that low point? What is that low value there? 1. It gets down to 1 and then goes back up. That's all. That's half of what you're doing in your homework today. Does that make sense? Okay, let's roll through the second one here. First thing, the vertex, I can see it. It's right there. It's a point. It's an x comma y, and this point is -2 comma 1. Now the axis of symmetry, like I said on the last one, I would like you to draw it. But then we have to state it. Remember, the axis of symmetry, it's not a number, it's a line, which means it's an equation, which means it's always going to be an x equals equation. And on that line, x always equals -2, right? -2, up, down. There we go. Now the zeros, this one does have zeros. Remember, the zeros are where this graph crosses the x-axis. The zeros are also points. They are coordinates, okay? Now, I know my graph isn't perfect, so just assume that they cross at nice even points. This 0 is at the point -3, comma 0. And then this 0 is at the point -1, comma 0. Good. Okay, the domain. If you were to guess, what do you think the domain is going to be? Yeah, it's always going to be all real numbers. The range, you do have to think a little bit. If you like the highlighting thing, I think it's going to help. You can't highlight the y-axis up here. There's no graph up here. The graph starts here, and this time it gets smaller. So y is less than or equal to 1, right? 1 or 0 or -1 or -2 or anything smaller than that. Now, does this graph have a minimum, a low point, or a maximum? It has a maximum. And what was that highest point? Is a 1. Okay, questions on those ones. You'll have 3 of those, just like that to do on your own, okay? All right. Now, this is the part that I wasn't sure whether to include this, but I just want us to get kind of familiar with the vocabulary, and whenever I say minimum, you can think in your head, minimum, okay? Or axis of symmetry, that's what I'm trying to get at here. It may be a crash and burn thing, we'll see, okay? So for each problem, we want to sketch a parabola that has the given properties. So for this first one, we want to sketch a parabola that has a maximum value of 4, and has zeros at -3, 0, and 2, 0. Okay, what I would start with is the zeros. I know exactly where those are at. -3, 0, and 2, 0. I know exactly where those are at. I know my graph, my parabola, goes through those 2 points. Now the next thing, it has a maximum. If it has a maximum, is this graph going to be going up or going down? If it has a maximum, it's going to be going down. So I know, and don't necessarily draw this, I know it's going to go through those 2 points and look kind of like that. Okay, now it's not going to look exactly like that because it has a maximum value of 4. So it needs to go through those 2 points, but it's not going to go any higher. And actually, it needs to go all the way up to 4. And then back down. I can get it to go through those 2 points. And you may have to, it doesn't have to be perfect, but see, it has zeros at -3, 0. It crosses at -3, 0, 2, 0, and it has a maximum, right? Highest value 4. Does that make sense? Okay, and then the last one. This one has an axis of symmetry at x equals -3 and has a minimum of -2. Okay, well, first thing, it has an axis of symmetry at x equals -3. I can draw that, right, as a dotted line, because it's not actually part of the graph. So -3, that line cuts my parabola in half. Now it tells me it has a minimum. If it has a minimum, is it going to open up or down? It's going to open up, right? It has a minimum, okay? So I know that my graph is going to open up, and that line is going to cut it in half. But it has a minimum value of -2. So it's going to come down, 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 down. It's going to hit -2, and then I didn't do that very well, but it's going to jump right back